Hi students, in this video we are going to discuss a couple of problems on chapter 5. Chapter 5 is present worth analysis. Basically in this chapter we are interested in calculating the present worth of a given cash flow or present value P, right? We know P, A, F. These terms we already know. We have discussed them in last few videos. So this particular chapter focuses on calculating value P given any cash flow. So let's discuss the first problem here. I'm gonna read the problem first. Find the present worth of the following cash flow diagram if I, which is interest rate, I is 8%. So cash flow diagram, probably you are hearing this term for the first time. Here you can see the cash flow diagram is given. So this particular diagram, you will see like many different cash flow diagrams you will see in future. Basically there is a axis there, and you will see the pay period 0, 1, 2, 3, 4. So that means this can be 1 year, 2 year, 3 year, or it can be 1 month, 2 months, 3 months, depending on or maybe 1 week, 2 week, depending on the context of the problem, right? If the units are not given, we can safely assume that as a year. So 1 year, 2 year, and so on and so forth. So this cash flow diagram is given for 10 years, and if you see the downward arrow, that means that it's a negative cash flow. And if you see upward arrow, that mean it will be a positive cash flow. For example, if you spend $100, that means you have a downward arrow indicating 100. The length of the arrow indicates the amount. They are not really very proportional, but the amount will be given below that arrow. So $100 is outgoing cash. That means you paid the money, or you spent the money, right? If the arrow would have been upward with the 100 number, that means you earned $100, maybe in a salary or some kind of income. So in this particular cash flow diagram, all arrows are indicating downwards. That means most of the cash flow is negative. All the cash flow is negative, right? But you may see in some of the problems, some arrows are pointing upwards, some arrows are pointing downwards. In sometimes during the same year you will see an upward arrow as well as a downward arrow. That means there is a income as well as there is a expense. So you will see all sorts of things, but for this one it is simple. It's mostly outgoing cash flows in each year, mostly negative cash flows, right? So let's see. So we need to calculate. We know interest rate is given as 8%, and we need to calculate the present worth P. That means what is the value of all this cash flow if we want to know the present worth of this cash flow, or P. How can we calculate that? So there are a variety of approaches we can use. For example, year 0, $100, right? Negative $100. That is if you want to calculate P, or present worth of this single cash flow, that is the same as it is, right? Because it is at the beginning, it's in the 0th year, $100. That means P for this particular cash flow is 100, right? Now the remaining cash flows are future cash flows, like in year 1, at the end of year 1, at the end of year 2. So they are, in a way, they are F values, right? F is equal to 150, F is equal to 200, F is 250 for different years. So what we can do is we can use, for example, if we want to find out, let's say the present worth of only these two cash flows, 100 and 150, maybe 3. Let's talk about 3 cash flows, 100, 150 and 200. We want to find out P. So what can we do? We type P for present worth is equal to 100. It's the P value of 100 is 100, so we type 100, right? Plus 150 is a future cash flow, so we type 150 multiplied by P given F. F is given, F is 150. We need to calculate its present worth, right? So P given F factor that we can find out from the compound interest tables at the back of the book. P given F, and then that is at I, which is 8% in this case, right? So 8%, and the N is the number of year. For the first in this cash flow $150, it's gonna be 1, right? Because it's end of first year. Then let's do for the second one. So $200 is at the end of second year. So 200, again P given F factor, P given F, 8% interest rate is same, but now the N, which is number of years, is 2, right? So this is 2, so we will write 2. So P given F factor will be different for this amount, and the same factor will be different for this amount, because that was at the end of $200 was at the end of second year, and the first $150 was at the end of first year. So, and we can, so basically this, if you solve this, you will get the present worth of these 3 cash flows. So we can do that for all of the cash flows. We can just keep going and complete the answer. That's one way of doing that. But if we have a number of cash flows, it would be difficult, or it will be too long to write down a formula for maybe 100 years. So what we can do is we can use a alternative approach if possible. So in this case, that alternative approach is used here. So P is equal to the $100, which is same in the 0th year, that is 100, plus we know that at least from the year 1, at least $150 was outgoing for each year. Minimum $150 was outgoing each year, right? Year 1, year 2, you can see year 3. So we take that 150. So that 150 is we can call it as an annual cash flow. We talked about this, right? Annual cash flow means it's a repeated cash flow. In fact, I can show you here the definition. Annual amount, uniform amount that repeats at the end of each year for n years, right? So we take that 150 is that amount we know. So we write 150, and we need to find out the present worth of that annual cash flow, right? So P given A, interest rate is not going to change, that is 8%, and you see N is 5, because we are only talking about the first 5 years. We're not going we're not going beyond that. So first 5 years. So that is that. Now but 150 was the minimum. We still have to think about the total amount, right? 200. So 150 we already counted out of this 200. Then only 50 is remained here, right? 150 already counted of this 250, so 100 remain there, 50 here, 100 here, 150 there, and 200 there. So we can see that there is each year the amount that we are spending is increasing by $50 right from here actually, increasing by $50, right? So what does that mean? That means there is another letter that indicates that uniform gradient amount G. That, what is that? Basically that is very similar to the concept of A. In case of A, it was a uniform amount. G is not the uniform amount, but it is the uniform gradient amount that repeats at the end of each year. Gradient means incremental amount, right? And if you look at the back of the book, the tables, you will see the factors for G as well. So we write down here plus 50, because 50 is the G value. We know G value is 50, but we are interested in its present worth. So P given G, 50 multiplied by the P given G factor. Interest rate is 8%, and we are just right now the calculations are going only up to the 5th year, right? So with this expression here, we have we will be able to calculate the present worth of all the cash flows up to year 5, right? That's what we did so far. But now we still need to think about the cash flows that are from year 6 to 10 onwards. So for that we need to add some other terms to the formula. So plus 300, that is 300 is coming from here, 300. And if you look at the cash flows from year 6 onwards, 300, 250, 200, 150, 100. So there is a gradient there, gradient Z. For the first 5 years, the cash flow was increased by $50 for each year, right? Going from here on this direction, the cash flow is decreasing by $50 each year from year 5 to year 10. So we already have calculated for up to year 5. For year 6 and onwards, we assume that 300 is A, annual cash flow from year 6 onwards. That's what we are assuming, right? 300 is annual cash flow from year 6 onwards. So we need to find out its present value, right? So P given A, interest rate doesn't change, and 5. Please note that this is 5. That means we are going to calculate the present value not here, not in the year 0. 5 meaning 1, 2, this you can see year 6, 7, 8, 9, 10. So this 5 years, so that means we are calculating the present value at the end of year 5, right? Because we are only talking about the second half of the diagram. If we want to calculate the present worth of that cash flow at year 0, that we will do afterwards, but right now we are bringing all these cash flows to its value at the end of year 5. We are first going to calculate the values of these cash flows at the end of year 5, and from there we will take it back to year 0, right? So from counting from here, only N is 5. So 300, P given A 8%, and N is 5 years. But 300 is not really outgoing each year. We have gradient 50 that is reducing. So we subtract the gradient from that amount. So minus 50 is a Z value. That's a uniform gradient amount, right? So P given Z factor we need. Interest rate doesn't change, and N is 5 because we are bringing the cash flow back to year 5, right? So that sounds good, right? So that formula gives us the present worth of this cash flow at the end of year 5. So that will be looking from year 0. If we are talking about year 0, that cash flow that we have calculated using this formula will be F value, right? Will be future value from the perspective of year 0. So that if that is a future value that we calculated, we need to calculate its present worth at year 0. So we can use the formula P given F. Correct? We can use the formula P given F. By using this first term, basically we brought the cash flows from year 6 onwards, 6 to 10 onwards, we brought them back to year 5. We calculated their value at the end of year 5. So that is a one amount F, right? From considering from year 0, that will be F. So P given F, we need to multiply the whole thing by P given F. Interest rate is again same, and 5, because we need from here we need to take it back 5 years, right? So N is 5. So that we did. So we need to solve this problem now. So I'm gonna just copy this and paste it one more time here. And then we can substitute the values of this. So I'm gonna look into the tables, compound interest table. The first value we need P given A 8%. So all of these values are at 8%. So we need to look at the 8% interest rate table. So I am scrolling down until I see 8%. So here we go. We have a 8% interest rate table, and we are looking at n is 5, that row. So in that particular row, P given A value is 3.993. P given A, right? 3.993. So we write that value here, 3.993. Here also the same value goes, P given A, 3.993. Now let's see P given G we need. So you can see here gradient present worth. Find P given G. So P given G, that is 7.372. So we do that. P given G is 7.372. 7.372. And finally we need to find out this factor, P given F. P given F, if the future value is given, find P given the future value, which is 0.6806. So we replace that 0.6806. So if you do this math, you will get this value, $1,631.97. That's the present worth, and it is negative value actually, because all the negative cash flows. So that is the present worth of this cash flow. Okay, so that is the answer. So I hope you got understood what I am trying to explain it here. If this is too difficult for you, as I suggested the alternative approach, you can consider each of them as a F value and then bring it back to its present value. But in that case you need to look at different, you will have to look at for example at 8%, 1 year values, 2 year values, F given P for 1 year, 2 year, 3 year, and so on and so forth. But maybe that is for some of you, maybe that is easy to understand, so you can do that. But this was why we use this approach, just to reduce the length of the problem, the length of the formula, because then we just needed 4 to 5 terms here in calculation. Otherwise we would have to do 10 different calculations, right, with 10 different P given F factors. So that is that. Now let's talk about problem 2. In problem 2 again, we are interested in the present worth. This is all this chapter is about. So let me read the problem first. A firm is considering the purchase of a new machine to increase the output of an existing production process. So basically the company is interested in buying a new machine. They want to increase their output, and a new machine would be able to increase the output for them. So they have some options which we need to look into. Of all the machines considered, the company management has narrowed the field to the machines represented by the following cash flows. Let's see. Machine, there are the options are, there are 5 machines that the management has narrowed down to, and each machine, the cash flow is involved with each machine. So initial investment, the second column, first column is different options, machines, right, 5 different options. Second column is about the initial investment, so investment in year 0, which is, this is already P values, right? And then we have a annual operating income. So if we draw the cash flow, this will be this is expenditure, right? It's an investment, so that will be negative, and income that we are getting because of that investment is given here, so those will be positive cash flows. So let's see, in case of a machine 1, maybe the cost of the machine is $50,000, that's the initial investment, right? And because of the increase in output, the annual operating income, additional income that the machine 1 will generate is $22,815, right? Same like you can see machine 2, it has initial investment of $60,000. This is a little costlier machine, but it also gives you more income per annum, right? Similarly, machine 5 is the costliest with $100,000, but it is also giving you $42,000, $42,485 per year income. So now the question is, which machine should the company choose? Some other information is given. Each of these machines are gonna provide service for 3 years. Okay, maybe after 3 years the machine life expires or whatever, but assuming that they are providing service for 3 years, and the minimum attractive rate of return. This is important. Minimum attractive rate of return. What is that? Is basically when a manager or a company decides to invest money in a project, they want a minimum rate of return. They want minimum rate of return for that investment because they are taking risks. The money could have been invested in some other investment, so they expect a minimum rate of return from the particular investment should be some X%. They don't want to go below that, otherwise they would not invest. So that is something called minimum attractive rate of return, which is I, again it is interest rate of return. So the company, for this company, that interest rate is 12%. So we know N is 3 years, we know that I is 12%, and now the question is, which machine should we select? So the idea is to calculate the present worth of each of these for each of these machines. Calculate the present worth of investment and annual income, and see we want the maximum value of P. Whichever machine gives us the maximum present worth value, we will select that machine. As simple as that, right? So the goal is to maximize the present worth. So we take that table. We have these are negative cash flows, these are expenditures, they are investments. So I put negative sign in front of all of them, right? And annual operating income, this is P values, right? These are P values, and these are A values. They are annual income, they are annual amounts, right? Uniform amounts, annual. Each year you get 22,815. So they are A values. So, and they are positive cash flow, positive values, income, right? So those values are there in the second column. And since they are A value and we need to calculate the present worth of that annual cash flow, we can use this factor here, P given A. Interest rate is 12% and N is 3, right? So we again go back to the table, look for the 12% interest rate table, which is right here, and N is 3. So N is 3, and we are interested in P given A, right? P given A. So that would be here, P given A, 2.402. So we multiply these numbers by 2.402. That's the same for each machine. So we do this multiplication. So that's a positive cash flow, and $50,000 negative. So you add these two values. This is already P, right? These are P values. We converted these A values into P values. So now we can add them. We can never add this. It will be wrong in any problem. If you try to add P value to A value or P value to F value, it would be wrong. All the values should be either in F term or in A term or in P term. You cannot add P's to A's or A's to F. That will be wrong, right? So now that we have converted everything to its present worth, we can add these two values. So that gives us a net present worth. That would be, if you do the math, it's a $4,802. So we do it for all the machines. So which machine do you think generates the highest net present worth? Machine 1, right? $4,802. So basically the answer is the company should select machine 1 for highest NPW value. Okay, so this is basically very simple problems. Once you understand them, it's fun to do these type of problems. So with this, I stop here.